Hello, my name is Professor Rad, and this is Precalc video 311, sinusoidal functions, writing equations. So in this video, we're going to be applying the formulas that we talked about in the last video to write equations of sinusoidal functions, either if we've been given information or if they've been graphed. So on the board over here to the side, I have our formulas that we looked at. So we have the amplitude and the period and the phase shift formulas. And I also have a little mini sketch of the sine and the cosine functions. And I've sketched them from negative pi to pi, just because I was limited on space over here. So what is helpful for me to remember is that sine starts at 0, 0, and cosine starts at 0, 1. So that helps me to identify whether I should be modeling a sinusoidal function with sine or whether I should be using cosine. In truth, you could use either one, because remember that we had those properties that showed that you could take the sine function and just shift it a little bit to the left and get cosine. Or if you have cosine, you can shift it a little to the right and get sine. So you can use either sine or cosine to model a sinusoidal function, but I personally find it easier to use one based off of the starting point, as opposed to just always using sine or always using cosine. So we have two functions that we're going to be writing the equations for, and both of them have been graphed for us, but we could also have been given information like the period and the amplitude and so on. So we'll see what that would look like as we progress through these examples. So before I go to write an equation, I do like to think about a few things when I go to collect information. So things I think about are, should I use sine or cosine? I also like to think about what is the amplitude? And I also think about what is the period? And what is a phase shift? If there is one. So these are the questions that I ask myself before I go to write the formula for my function. And then once I have these answers, then I can write the formula. So when I look at this first question, should I use sine or cosine? What stands out to me is that I'm hitting the y-axis on the x-axis, or sorry, on the y-axis at one of my extreme points. So what this says to me is I should be using cosine. The reason I should use cosine is because the peak of cosine hit on the y-axis. And so that's what's happening here. We have a peak happening on the y-axis. So I'm going to use cosine to model this function. For the amplitude is the distance from my x-axis to that extreme point. So because I'm hitting here at -4, the amplitude is going to be 4. You can also check in the positive direction. So the height of the function is here at 4 as well. Next, I try to identify the period. The period is how long it takes before the function fully repeats. So you just pick a starting point and an ending point, and then you can subtract. So for example, to make my life easier, let's start with this as our starting point. And then I'm going to keep going until I get back to that point. So So it took me from 0 to 6 pi to get the full sense of our cosine curve. So that means that the period is going to be 6 pi. Now, just to show it doesn't matter which points we start at, suppose I had started at, say, this point instead. This point would be at -7 pi over 2. Or sorry, 9 pi over 2. So if I'm starting here, I would get the full sense of the function up until 3 pi over 2. So I could do 3 pi over 2 minus a -9 pi over 2. So that'll be 3 plus 9, which is 12, and 12 pi over 2 also gives me the 6 pi. So it doesn't matter where you start and end at. What you're looking for is a full iteration of your curve. Then for the phase shift, on this one, I'm not going to use a phase shift because our extreme point happened right on the axis. But I'll point out in the second example that we're going to do, notice that this extreme point doesn't happen on the axis. So either this point or the point where we cross the x-axis doesn't happen on the y-axis. So this one I'm going to use a phase shift for. This one I'm not. But there is something mysterious happening with this graph, or something a little bit not so nice. And what's the little bit that's not so nice is that this extreme point here is at the bottom, right? So this is where our cosine curve is bottoming out. When we look at our base function that we're going to be basing off of, it tops out there. So instead of shifting this function, I'm going to think about, I took my cosine function and I reflected it so that I would get the bottom happening around the y-axis instead of the top happening. So, but it's going to have a reflection. All that means is that A is going to be negative. All right, so that's my first pass at looking at this function. I've collected a bunch of information. So I've figured out what function I'm going to use. I know the amplitude and the period, and I know whether I'm going to have a phase shift, or in this case, I'm going to have a reflection. At my second pass through this, now I have to figure out what are the values for, I have room over here. What are the values going to be for A, omega, and phi? Because these are the values that we need to write the name of our function. So because we don't have a phase shift, phi is going to be 0 for this function. A is going to be based off of your amplitude and whether or not you have a reflection. So because we have a reflection, we know that A is going to be negative and that the amplitude is 4, so we'll have a -4. This is because our formula for amplitude is the absolute value of A. So we need the A value to equal our amplitude, and we need the sign to indicate whether we have a reflection or not. And I saved kind of the longer one for last, omega. So I saved that one for last because the formulas that involve omega are our phase shift and our period. Typically, I use the period formula to find omega because we don't always have a phase shift. Like on this one, we don't have a phase shift. So I'm going to write down my period formula here. So T is 2 pi over omega. I know that the period is 6 pi, so I can write this as 6 pi is 2 pi over omega. And now I can solve this equation for omega. So the way that I'm going to do that, let's multiply both sides by omega. So we get 6 pi omega is 2 pi. And then we can divide both sides by 6 pi to get omega is equal to 1/3. So omega will be 1/3. All right, we're just about done. We're ready to write our function now. This function's name was f of x. So we're going to start out with f of x. And the main structure for this is going to be A, either sine or cosine. So in this case, cosine, omega x minus phi. So for this case, A was -4. We're using cosine. And omega we found was 1/3. And because there was no phase shift, I don't have to worry about phi. So here we go. Okay. So this first example is an example of writing an equation for a sinusoidal function that does not have a phase shift. Now let's do an example for a sinusoidal function that does have a phase shift. All right, so we've cleared out our answers from the previous example, so we can work on this second one. So for the second function, which we're calling g of x, we have our sinusoidal function, and this time we don't have one of the nice sine or cosine points happening on the y-axis. So when I analyze this function, I can use either sine or cosine. It just depends on where I want this function to like start. So for example, if I think of this as my starting point, then I can think of this as looking like the sine function that's been shifted to the right a little bit. So if I want to use this as my starting point, I can use the sine function. But if I wanted to use, say, this point here, if I wanted to use this point, then this I could think of as like my cosine function that's been shifted to the left, because cosine would ordinarily hit up here, so I could shift it left so that it was starting here instead. So you can also use the cosine function to model this. So I'm going to use sine because we used cosine for the last one. So I'm going to use the sine curve. Also because this shift is a little bit smaller, so it'll be easier for me to kind of, maneuver with. For the amplitude is the distance from the middle up to the top, or from the middle to the bottom. So in this case, they've indicated that we're passing through the point 3, 7. So that means that this space is a distance of 7. So our amplitude is going to be 7. For the period, we want to see how long it takes for one full cycle of the sine function to pass through. So, you golly, I'm actually going to look at it going this way because I don't have enough of the graph going that way. So if I start here and work backwards, we have the bottom lump up through to the top bump, and then we hit here. So we can think of one portion of the sine function starting at -7, and then it goes up until +1. So if I do 1 minus a -7, that's going to give me 1 plus 7, which is 8. So the period of this function is 8. So the period is 8. Now for the phase shift. So the phase shift is where my starting point is at. So because I chose to start at this point here, I'm going to say that the phase shift is 1. If I had chosen to use cosine, and if I had chosen this as my starting point, then my phase shift would have been -5. Or if I had started this one, chosen this one as my starting point, my phase shift would have been 3. So wherever you're starting your function, wherever that starting point is that you're using for reference, is going to be the phase shift that you incorporate. So there really are quite literally infinitely many equations that we can use to model these functions. So there's no like one right answer, plenty of wrong answers, but plenty of right answers as well. That's what makes it nice and confusing. Yay. But we've got all this information. So we've gone through our first pass of looking at the graph. Now, I'll also point out you could be given this information and not a graph. So you could be given, say, use sine to model a sinusoidal function with an amplitude of 7, a period of 8, and a phase shift of 1. So you could be given all this information just in text or in words without the visual, and you would just be able to skip this first step of identifying what those things were, and then you can move on to these next steps. So for our next steps, we need to figure out A, omega, and phi. So A is the easiest one to figure out because remember the absolute value of A is your amplitude. So we get the value for A from the amplitude. So our amplitude was 7. So A is going to involve a value of 7. And then to determine whether it's positive or negative, think about whether or not you're reflecting the function that you're using to model your graph. So in this case, because I chose this as my starting point, it's going uphill first and then downhill as I progress from there. And that's what the regular sine function does. It goes uphill first and then downhill. So I'm going to have a positive value for A. If, however, I had started here at -3 and I went downhill and then uphill, I would have been using a -7 for A. So again, it's going to depend on where you're identifying that phase shift to be, where that starting point is going to be. Next, to figure out omega, I'm going to use my period formula here. So we have T is 2 pi over omega. Or actually, if you wanted to, you could multiply by omega and then divide by T. So if you'd like to remember another formula, you can. You can remember that omega is 2 pi over T. It's the same as this formula, just rearranged. So our period was 8. So that means omega is going to be 2 pi over 8. So omega is going to be pi over 4. Then in the first example, we didn't have to worry about phi. It was going to be 0 because we weren't incorporating a shift. But now, because there is a shift, we are going to have to incorporate phi. So the phase shift is equal to phi over omega. So we know that 1 is going to equal phi over omega. We just found omega to be pi fourths. So 1 is going to be phi over pi fourths. And I can solve this for phi by multiplying both sides by pi fourths. So we have pi over 4 is equal to, that's a weird looking, phi. Pi over 4 is equal to phi. So we get pi over 4 here as well. All right, so now that we've identified A, omega, and phi, we can use them to write the equation of our function. So I'm just going to give myself a little bit of space here. So we're going to say that since we're using sine, we're going to say g of x is a sine omega x minus phi. So g of x is going to be 7 sine of pi over 4x minus a pi over 4. There we go. All right, so that's going to conclude this video on writing the equation of a sinusoidal function. In the next 3 videos, we're going to be going backwards. So we're going to be taking the equation of our trig function and then going ahead and graphing it. So one reason that process, the graphing, is a little bit trickier is notice that for both of these graphs, my x-axis has very different scale. So on this one, my x-axis, I counted by 3 pi halves instead of pi halves, which is what we normally do. And then for this one, there's no pi involved at all because of what our omega value ended up being, kind of canceled out the pi. So you can get some weird stuff happening with the x-axis. So that's where most of our focus is going to be in the next 3 videos, is figuring out what that x-axis should be. And then once we have that, how we can graph these points to help us graph the trig function, and then we'll just go ahead and graph it. So in our next video, we're going to start out with a simple example where we don't have a phase shift. And then in the next 2 videos, we'll be doing phase shifts for our graphs. So looking forward to seeing you for those examples. In the meantime, I hope you found this video helpful in writing equations of sinusoidal graphs, and I hope you have a fabulous day. Bye for now.